Hello everybody, this is video on part 2 about the chapter on Z over NZ sets. So if you remember what we've seen in part 1, actually Z over NZ is a set of equivalence classes where all the elements from 0 bar to n minus 1 bar represent a set of numbers with the remainder of the Euclidean division by n. For example, 1 bar is a set of further numbers whose remainder with an Euclidean division by n is equal to 1. So actually, the elements of Z over nz are not numbers. They are sets. Nevertheless, we can make some operations that will really look like some standard operation we already know. The first one is a sort of addition, and it's a plus with a circle plus, just to make the difference between the standard addition we know and the addition in Z over NZ. We also have a multiplication operation, which is a circle x or circle times operation. So how do those operations work? Actually, they are not very far from what we know with standard addition in multiplication. For example, let's take any two elements from Z over NZ, then their addition is equal to A plus B modulo n bar. So that would be quite easy to prove, but let's start with this definition. Again, for multiplication, for two elements A bar and B bar in the Z over NZ set, we will have quite the same thing, that is A bar times B bar is equal to A times B, where A and B are numbers, it's standard multiplication, modulo n. So actually, during some calculations, actually, we will choose to apply or not modulo n, because we are very free with respect to making calculation modulo n. So that's, let's say, quite easy to understand. And let's take an example, and you will have a video with all the examples from the lecture, actually pages 11 and 12, so that you can train yourself. Example, for n equal to 11, Z over 11Z is a set of all elements from 0 bar to 10 bar. And for example, if you want to make an addition of two elements, so always be sure that you know the value of n when you do the calculations. Actually, depending on the value of n, a calculation won't give the same result if you take any two elements. For example, 6 bar plus 8 bar is equal to 6 plus 8 modulo 11 bar, which is 14 bar. So you can write 14 bar as some kind of intermediate results, but actually 14 modulo 11 is equal to 3. So 6 bar plus 8 bar is equal to 3 bar in Z over 11Z. So actually, during the calculation, let's say that something that would be okay is that 6 bar plus 8 bar is equal to 14 bar, But in the end, you should always find a number which is between 0 and 10 under the bar. Let's say that this 114 bar is just an intermediate step in order to get the results. So that would like, okay, in any exercise or in an exam, for example. Okay, so I hope you understand how calculation works. Let's make just another example still for n equal to 11. Let's multiply two number, make the simplification. Then in the next video, I will take some example from the courses and another video with other examples. So let's go for multiplication. 7 bar times 5 bar is 7 times 5 modulo 11 is 25 modulo 11. And actually, if you divide 35 by 11, the remainder will be 2. So 7 bar times 5 bar is equal to 2 bar in Z over 11Z. Actually, if n were to be different, actually this calculation would give another result, for example. So always be careful when making calculation in Z over in Z to always use the value of n to end with your results.